it's normally quite difficult to create that thrust chamber or nozzle, because you've got to create an inner jacket, outer jacket, kind of machine the inner jacket, and then braze the whole thing together. It's a real pain. And you've got a bunch of joints in there to make it all work. So with printing, you can print something that you can't make by any other means. So it actually ends up being lighter and cheaper than if we built it by traditional methods. For our next generation engine, which we call the Raptor, which as I mentioned is sort of it's a deep cryomethalox. So what I mean by that is the methane and oxygen are cooled to close to their freezing point, so not far from their freezing point, as opposed to close to their boiling point, which is normally the case. For that engine, we're trying to print as much as possible. It's a bit the biggest limitation on 3D printing right now is the size envelope. So there's a limit on how big we can print something, but we're able to print the turbopump components and much of the injector, not the whole thing, but many of the critical parts we can print. So that actually helps us in speeding up the development. So instead of waiting for castings to be developed, which can take several months, and then if the casting is wrong,